Good morning students, I am Vetri Chelvi from Vetri and Vetri NEET Chemistry. Today I am going to give the NTA Abhyas 5. Question number 30 onwards, this is belonging to part number 5. So till part number 4 I have completed the questions. That till part 4 all the questions seems to be a simple, but this part is going to be a very challenging question. Please don't miss even single minute. Now let us go to the question. At a constant temperature, which of the given aqueous solution will have the maximum vapor pressure? Molecular weight of sodium chloride is given, sulfuric acid is given. So, at constant temperature, which is given that maximum vapor pressure. So, before going to the thing, what are the options are there? So, you are provided with 4 solutions are available. So, one is the 1 molar sodium chloride, another 1 molar sodium chloride, and 1 molar sulfuric acid and 1 molar sulfuric acid. That means like that you are provided with the 4 samples of liquids are available. They are asking which of the given you will having the maximum vapor pressure. Who is having maximum vapor pressure is the question. Okay, now let us see relationship between the vapor pressure with the concentration. Now before this is the relationship, before going to that let us see the knowledge. This is we are keeping as the water. You find out the vapor pressure, we are giving us the P0. So to that you are adding some substance. Now we are measuring, it is called P. What is it? Always P0 is greater than P. What is the thing is, always vapor pressure of the pure solvent is more, or I can say when add anything, I can say the concentration increases, vapor pressure is decreases. On the concept you write, vapor pressure concentration is inversely related. So this is the first. Okay, to understanding if you are writing mean you never forget. For understanding only I gave this picture. So concentration increases, vapor pressure decreases. They are inversely related, point number 1. Next what is called I is called as a want of factor. Here you are provided the 2 chemical. One is sodium chloride and sulfuric acid. Regarding sodium chloride and sulfuric acid, I is the number of ion. Sodium chloride is having 2 and sulfuric acid is having ionized to give 2 H plus and SO4 2 minus. Totally you are having 3 ions are available. So among this you are having what you should have it. What I want is coming. This is what is available I gave here. And what is the relationship with it? What you want? I want the maximum vapor pressure among the 4 sample. Now let us see the condition for maximum vapor pressure. One angle you think, then only you can do very faster manner. I want maximum vapor pressure means the concentration should be less, the I factor should be less. That is written here. Now compare first I factor. This is less. So among these two you select sodium chloride. So now options are now in between only sodium chloride only. So these two we will eliminate. Next thing is what is given is 1 molar and 1 molar. Now I am comparing what very basic knowledge. 1 molar solution of sodium chloride meaning that is here diagram is easy. 1000 gram or I can say it is 1 kilogram you are adding the salt. Here what is molar mean? To the solution you are adding, how they are doing is, how they will actually prepare is, in standard flask they will take the, what is the thing, 58.5 grams of sodium chloride first they will take it. To that they are adding water little by little, then it is make to 1 liter, then it is bring to 1 liter. That meaning the volume is actually 1 liter solution. 1 liter solution mean volume is what happened is decreases. Volume decreases mean concentration increases. This is standard process. How to prepare this 1 liter solution I have demonstrated. So what you are doing? 1 kilogram water to that adding. So more water, that is volume is increases, concentration is decreases. This is enough. What I want? Less concentration. So who is having among these two, who is having less concentration? This is. That is molar is less concentration. So you put this is. Okay, very beautiful question, very interesting knowledge. With that I am going to the next question, question number 31. Now let us see the question number 31. When two reactants A and B are mixed to give a product C and D, the reaction quotient Q at the initial stage of reaction is best described by. Now let us write. Very simple only, for understanding only I am giving. A plus B gives C and D. It is at equilibrium. Initially what it is, it gives like this. Okay, what is Q? Q is equal to concentration. This is your formula. Okay, for simple I am giving example. For initially, let us have this one is having the 5 and this one is having 10. Because initially it is 0, process started with going on forming. So let us assuming this is initially started with 10. Okay, after 5 minutes or 10 minutes you can see what you have produced is 5. Now quotient you are keeping as a 5 by 10. Now what is a 5 by 10 is 1 by 2. Now let us go till that time is increases. More and more CD is produced. So what is more and more CD means? Now 5 to it is increased to 8. Now initially is 10 only. Now what you are getting is 4 by 5. Now what is the 4 by 5 is less than your 1 by 2. Okay children, now 4 by 5 your answer fraction you are getting is 0.8. Previously it is 0.5. So what happened? It is increases. So Q value increases with the time at initial stage. This is simple knowledge. Okay, next we are coming to the next question. Which one of the given reaction of xenon compound is not feasible? So which will not take place? Let us see just at a glance we will able to find out xenon tetrafluoride and this is where xenon difluoride. These are the hydrolysis and this is very direct NCERT knowledge, so it is possible. Regarding this, there no such reaction is available, but beyond that the knowledge is, since you are here the knowledge for this reaction I am giving, it is possible. Of course I am going to give the answer. What is it? It is knowledge is xenon is this one central metal atom, xenon is acting as a Lewis acid. What is a Lewis acid? Knowledge is accept of electron pair. So your fluoride ligand is giving, your xenon is accepting because it's having 8 valence electron. 8 valence electron, 7 is consuming, that means it is able to what is called accepting. So because of that the complex formation is possible. So which is not feasible is, the answer is this reaction is not feasible. So your answer is this is because they are asking. So these three are possible. So whereas this is not possible. Why it is not possible? That reason is, why it is not possible? Reason is here itself. Xenon oxide with the HF, it gives the, what is this? Xenon hexafluoride forming mean, this again dissolves in water. You can see here like 2 and 4, it dissolves in water, hydrolyzes and gives back to this one. So forward reaction is not possible because of the product is hydrolyzed and give back to the reactant. So your answer is A. Now we are moving to the next question. Question number is 33. Very interesting question. Now the question we will see is, consider the reaction A gives 2B plus C, one reaction, where the delta H is equal to minus 15 kilocalories. The energy of activation of backward reaction is 20 kilocalories. Now let us take the, underline the knowledge. It is the energy of activation for backward is 20 kilocalories per mole. In presence of catalyst, the energy of activation of forward reaction is 3. Okay. Energy of activation of backward reaction is 20. In presence of catalyst, the energy of activation of forward reaction is 3 calories. Okay. At 400 Kelvin, the catalysis causes the rate of the forward reaction to increase the number of times how much equal to. So first number, by adding the catalyst, the rate is what is called increases. That means energy of activation is decreases. Now let us see this graph. Energy versus the progress. Now this one is called a reactant and this is the product for exothermic reaction. This is exclusively for exothermic reaction. Reactants reaches the activating state and it gives down the products. Okay, how you have to label is this one, this level, that is different between this and this is called as a change in enthalpy is equal to minus 15 when the sum it is given. So delta H value is, now it is formula is delta H is equal to energy of activation of forward minus energy of activation of reverse. This is the formula. Now delta H value I am writing, it is the minus 15. Of course unit is written as the kilocalories. Okay, and then what is given is here in this diagram, from here to here it is energy of activation of forward. For here to here it is energy of activation of the, you can see the sign, it is the reverse. Okay, reverse is given as the 20. You can see children, from the diagram I am taking, energy of activation of reverse is 20. Okay, what is the energy of activation of forward? This is, you may not know for the initial state. So you want this is in, you bring the minus 20 on plus here. So what is our answer is, the difference is 20 minus 15 is equal to energy of activation of forward. What we are getting is your, what is it called, the 5 unit is kilocalories per mole. So this is for the first condition from the diagram we have calculated. Next what is given is, in the presence of catalyst the energy of activation of forward is 3. So now this is we are taking as a K1. Now we are taking this is the K2. In that one energy of activation forward, from the sum it is given as the 3 kilocalories per mole. Okay, now the temperature is given, temperature is equal to 400 Kelvin. Okay, now let us see the relationship between how we are going. This diagram is to find out the energy of activation for forward only. Beyond that the diagram is not related with the sum. Now this is the next part of the sum. Now what is it? K is equal to A e to the power of minus EA by RT, of course we know. You take this is ln K, nature log is equal to ln A plus ln E minus EA by RT. Next ln A plus you bring here minus EA by RT ln E, and now this ln E is equal to 1. So now it is ln A minus of EA by RT. You bring here, this is the relationship. Now this relationship we have to write it for the K1 and K2. When you are writing K1 activation energy is 1, K2 is activation energy is 2. You have to proceed in such a manner, you have to cancel this ln A and A. Since with the what is the plus and minus, we have to do is subtraction of the equation 1 from the 2. Okay, now what we are doing is ln K2 minus ln K1 is equal to 2 minus 1. ln A is getting cancelled. Minus EA2 by RT minus of minus plus EA1 by RT. Okay, now it is, you can write ln K2 by K1 is equal to 1 by RT is common, bring it out, and what we are having is this. What we are having is this is EA1 minus EA2, bring into the bracket. So EA1 minus EA2. So the formula we have arrived is this is. Now let us write, substitute the values. EA1 minus EA2. Okay, what is the energy of activation? Now here it is written. EA1, it is another K1, EA1 is equal to K1, so it is EA1 is equal to 5. So next one is 3. So 5 minus 3 is written here. Since it is written in the value units of it is the, here of course here I have written it is a kilocalories. So the kilocalories converted into the calories into 10 power 3. Now the denominator R and T. So 5 minus 3, 2 into 10 power 3. Now in the denominator 2 calories into temperature is 400. Now what is it? You can hear 2 into 10 power 3. So yes, now what we are cancelling. So 10 power 3 is 1000 divided by 400. So 10 by 4 is you are getting 2.5. Now what is this is ln K2 by K1. To remove ln, what we have to do it is, for this simple explanation is formula is given. Ln e power x is equal to y. I want to remove ln means, that is x is equal to this e is become coming here. So e to the power of y. What we did it for log. Log x to the base 10 is equal to y. You want x mean anti-log of your y. That is you bring the 10 to here. 10 power y. So same knowledge here. So x is equal to e to the power of y. Now let us here. I want to remove this ln. So to remove ln, I am introducing e. So K2 by K1 is equal to e to the power of 2.5. That is K2 is equal to e to the power 2.5 times of k1. So your k2 is this much time. First step. With that we are coming to the conclusion now. Your option is your B. So option is B, children. So here I am just repeating the points. First, this diagram, you write this formula is important. Exothermic delta H is equal to energy of fluctuation of forward minus reverse. With that you are finding out, and then you are following this one and finding the answer. I am going to the last question. This is a very simple question. The enthalpy and entropy change for the reaction is, that is 30 kilojoule, and the units is very important. 105, both are the different unit. The temperature at which, this is very simple question. 2019 also the same pattern is came. Now let us write here. You write it is respectively enthalpy and entropy. Here it is kilojoule and joule. What is the thing is, condition is given as a equilibrium. At equilibrium delta G is equal to 0. So this is here, it is kilojoule to joule. It is, so for that conversion it is written. Okay, you want a minus t, bringing the t into here, t keep it on the next side, you are bringing here. Now what is this is the, here you have to approximately one simple trick. 105 I am taking as a 100. 100 means 10 square. Okay, it is on getting cancelled 10. That is you are having answer is 300 Kelvin. Now I am going to and see is what you are having is, it is approximately only 300. Don't take it as a correct word. Okay, so your answer is, don't pick 300, approximation. Now simple one. It is 100 means 300. If you are increasing 105 means, it is decreases to the 300. That means less than 300. Your answer less than 300 is your 285.7. Thank you, children.